As the developer and supplier of software programs for the analysis of the flow of students through a study course, welcome to StudentFlowPatterns. This very useful software can be downloaded from our website www.studentflowpatterns.com. Therefore, if you are a lecturer or a course manager or course funder for a study course and wish to get help to improve its performance, you have come to the right place. Downloading this software is real value for money for the following reasons. This is the first software program providing a scientific and comprehensive approach for analyzing flow patterns of students through a course. The software program does not operate at the level of the microdynamics of flow patterns, but follows a macro approach which is easy to understand without requiring extensive mathematical background. The software program is able to run on its own without being connected to the large databases used by post-school institutions for cohort studies and similar types of analysis. The software program, in essence, creates a virtual laboratory for testing and experimenting to identify solutions for improving the performance of study courses. The Excel software on offer comes in separate versions for the analysis of student flows through 2-year, 3-year, 4-year, and 5-year study courses. We can also provide a 3-page report on the analysis of flow patterns through your course based on information supplied by you for the course. Many views exist among lecturers on how the performance of a study course could be improved. Some of these include the pursuit of better graduation rates, getting students to graduate in shorter time, preferably in minimum time, the unfortunate position of dropout students, which needs to be dealt with, and the importance of managing the pass rates of students. Despite the fact that all of these actions have merit and are very relevant, no systematic approach had been available up to now as to how these different interventions should be combined to obtain the best performance results. Fortunately, however, new research has now revealed that all these different interventions are in fact related to one another, and that they all live together in a cleverly constructed triangle describing the flow of students through a course. The secret is that the flow triangle provides for all flow possibilities of students through the study course in terms of combinations of the so-called nominal size H of the course, which are the student enrollments, and the academic size S of the course, which are the module credits already accumulated. A study course having specific H and S values is shown as point Y in the diagram. The flow performance of students through the course is simply defined by the performance line given by the ratio S over H. The best performance, namely 100%, is found at the top left-hand corner X of the triangle. In short, the performance line is used to sweep the position Y of the study course into the best performance corner. The recent theoretical work also reveals that the position of Y is connected to each of the improvement interventions mentioned earlier on and in the following way. A constant graduation rate of students is associated with the horizontal dotted line through the point Y. A constant average number of years for students to graduate is associated with the slanted dotted line through the point Y. A constant average number of years for students to drop out of the course is associated with the position of the vertex W of the flow triangle. The performance of the study course at Y can therefore also be improved by pushing the graduation rate line upward, by rotating the slanting line anti-clockwise, and by moving the bottom corner W of the flow triangle to the left. The software also provides for the possible increase and decrease in the average annual intakes of students in, something which continually happens in real study courses. Growth changes the shape and position of the flow triangle, but does not change the fundamental characteristics of the flow diagram. This shows the flow triangle for a 5% increase in the average annual intakes of students in, with the flow triangle being displaced towards the right. This shows the flow triangle for a 5% decrease in the average annual intakes of students in, with the flow triangle being displaced towards the left. Finally, the StudentFlowPatterns software also includes another great feature, which allows for a calculation of the costs of a study course at any position Y within the flow triangle. This is done by using the so-called full-time equivalent student number for the course as a proxy for costs. Without going into the detail, the auxiliary diagram at the bottom of the flow diagram is a great tool to understand the technical details involved. This includes detail about the failed module credits, which is also connected to the pass rate of students. For the first time, we can now observe patterns of cost per student intake or cost per graduate for various positions of Y. For example, the cost per graduate at position Y is 4.76. Finally, the StudentFlowPatterns software is powerful enough to analyze more complex problems. For example, finding the performance targets for study courses offered on a part-time basis rather than on a full-time basis. Also, it provides the answer as to whether a struggling 3-year course should be replaced by a 4-year course or not. It is trusted that the software will allow you to fully understand the fundamentals governing the flow of students through a study course, and that you will be in a better position to formulate strategies for improving the throughput and cost efficiency of study courses. Each study course requires a unique intervention determined by the particulars of the flow pattern and the efficiency targets to be achieved. I thank you.